Calculus, Unit 4, Day 28, Part 4 notes. The last page here. For what values of x will the curve x cubed plus y cubed equal 4xy plus 1 have a horizontal tangent? Show your work and explain your thinking. So a horizontal tangent tells us we want a derivative equal to 0 because that's a slope equal to 0. So I'm going to take the derivative of this implicit equation and set it equal to 0. And those values will give me the horizontal tangent. So let's do that. So let's start with the derivative of x cubed is 3x squared. Derivative of y cubed is 3y squared. Now the difference is, what we've been doing in this section is it's going to be dy dx. Derivative of 4xy, again, it's going to be the product rule. So we're going to treat it as 4x times y. So derivative of the first is 4. Again, 4x, derivative of 4 times y. Now the derivative of y, well, we'll do derivative, leave the 4x the same, and then derivative of y is 1, and then dy dx. And then lastly, the derivative of 1 is just 0, so I'm not going to write that. So our goal is get all the dy dx's on one side. Let's bring them all over to the left. So 3y squared dy dx minus 4x dy dx. Get everything else on the other side. So we'll have 4y minus 3x squared. Now let's factor out dy dx. And I'm going to do this so when I factor out dy dx, I'm left with 3y squared minus 4x. Then I'm going to divide both sides by that. So I'm skipping a step here. We can talk about that in class if you're not sure what I did. I'm left with divided by 3y squared minus 4x. So to have a horizontal tangent means the dy dx equals 0. So if I had set this derivative equal to 0 and I multiply both sides by the denominator, then I'm just going to end up with the numerator equal to 0. So let's now solve this for y. So I'm going to add 3x squared to both sides. I'm going to divide both sides by 4. So I get y squared equals 3/4 x squared. And now what I'm going to do is I'm going to substitute that back into the original equation. Once again, my numerator is just 4y. So I got to get rid of that squared, get rid of that squared, get rid of that squared. Okay, I'm sorry. So that's y equals 3/4 x squared. So now let's put that into the original. X cubed plus y squared, x cubed plus y cubed. And I'm going to put in that 3/4 x squared in there, and then I have 4xy. Every place you see a y, I'm going to put in 3/4 x squared, and then plus 1. And now I'm going to substitute those values in, and I'm going to be able to solve and get some values of x. I'm going to need some more space to do that. Let's first put in the 3/4 x squared. 3/4 x squared. Okay. And so I'm going to keep working down here. 3/4 cubed is going to be 27/64. X squared, all cubed, is going to be x to 6. And again, that x squared is not in the denominator, although it looks like it right there. Equals, and then 3/4, the same thing, going to be 27/64, but that's going to be, oh, that's just 3/4 x squared. So these 4's are going to cancel out, so I'm just going to get 3x cubed plus 1. Let's bring everything over to the left and rewrite it in descending order. So 27/64 x to 6 minus 2x cubed minus 1 equals 0. I can then either, a couple things I could do. I could put it in the quadratic equation, because that's squared of this. I could use my graphing calculator. And let's just use our graphing calculator and let's get x equals negative 0.770 and x equals 1.732. And that is what we're going to get for when does this original equation x cubed plus y cubed equals 4xy plus 1 have a horizontal tangent. And it has a horizontal tangent when x equals negative 0.770 and x equals 1.732. Okay, we're going to go on to the next one. And I'm just going to have to move some work we did there. So the next question really just says, hey, for that previous problem, describe the values of x for which x cubed plus y cubed equals 4xy plus 1 will have a vertical tangent, and a vertical tangent has a slope that's undefined. So now we're going to take this denominator and set it equal to 0. So this is a little bit easier to work with. So we get 3y squared minus 4x equals 0. And so now negative 4x, and again it was in terms of y, negative 4x equals negative 3y squared. Let's divide both sides by negative 4. So x equals 3/4 y squared. And again, what did we just find out? We just said, again, we're talking about the curve has a vertical tangent when the denominator equals 0. And again, when does that occur? When dy dx is undefined. And when does that occur? That's when the denominator equals 0. Okay, good. All right, last two problems here. Okay, the last two problems, you'll notice they have this d squared y over dx squared. This is actually talking about the second derivative. Okay, so what we have to do first is find the first derivative. So the first derivative, again, derivative of y squared is going to be 2y, but then dy dx. Derivative of 2y is going to be 2, again, dy dx. Derivative of 2x is 2, derivative of 1 is 0. So now let's factor out that dy dx, and we get 2y plus 2 equals 2. Divide both sides by 2y plus 2, and we get 2 over 2y plus 2. That's the first derivative, and I should actually take out a 2 there, so it's going to be 1 all over y plus 1. I can take a 2 out of the numerator, 2 out of the denominator, and we get 1 all over y plus 1. Okay? Now what we want to do is take the second derivative. So to do that, I'm going to take the second derivative, and when I take the second derivative of this, that's the quotient rule. So it's Hody high minus Heidi ho. So take the denominator times the derivative of the numerator, which is 0, so that'll be 0, minus the numerator times the derivative of the denominator. Derivative of y plus 1 is just 1 dy dx all over the denominator squared, y plus 1 all squared. Okay, so now let's simplify this. As we said, that's going to go to 0. So we get 1 times dy dx. Hey, what did we say dy dx is? That's right up here. That's 1 over y plus 1. So let me write this down. So the second derivative equals negative, there's a negative right there, dy dx, go up a little bit, is 1 over y plus 1 all over y plus 1 all squared, and this is going to be equal to negative 1 all over y plus 1 all cubed. So that is the second derivative of our original problem, y squared plus 2y equals 2x plus 1. All right, we're going to do the same thing on the next problem. So let's find the second derivative of x squared plus y squared equals 1, which hopefully we see that as being a circle. And right there is the second derivative. So derivative of x squared is just 2x. Derivative of y squared is 2y dy dx. And the derivative of 1 is 0. So we're going to keep all the dy dx on the left side. Move the 2x to the right side. It's going to be negative. We're now going to get dy dx by itself. So I'm going to divide both sides by 2y. So we get negative 2x over 2y. 2's are going to cancel out. So negative x over y. That's the first derivative. Now we have to take the derivative of this. So that is the second derivative. And again, it's taking the second derivative of y, again with respect to x. So it's the quotient rule. So it's going to be denominator, Hody high. So y times derivative of negative x is negative 1 minus, leave the Heidi ho, so the numerator times the derivative of the denominator, which is 1, but then I get, because derivative of y is 1, but then dy dx all over y squared. Okay, now we got to simplify, and again, this is that other problem. So every place I see dy dx, I can put in negative x over y, so let's just write down what we have there. So I get negative y should be plus x. But every place I see dy dx, I'm going to put in negative x over y all over y squared. So now I have to find a common denominator, which is going to end up being so I just simplified that a little bit, and let me get a common denominator here, y and y. So we're going to have negative y squared. Let me write the numerator. First of all, second derivative equals negative y squared minus x squared over y times, and since we're dividing by y squared, it's going to be multiplying by 1 over y squared. And so now this is going to be the second derivative is going to be equal to, and I'm going to factor out the negative from the numerator. First of all, y times y squared is y cubed, and when I factor out that negative, it's just going to be x squared plus y squared. A couple ways you could write that. Okay, that's the second derivative. And these were all dealing with implicit equations where we took the implicit differentiation. Okay, and that's it for day 28 notes.